NASA has announced that Explorer 1, the most distant man-made object in space, is once again sending useful data back to Earth after traveling nearly 14 billion miles from the planet. Explorer 1 has made a discovery of great significance and is now turning its mission around to face Earth. But what exactly could this discovery be? Could it be evidence of extraterrestrial life, a valuable anomaly, or something even more inscrutable? In this exciting investigation, we will uncover this surprising discovery through the shocking discovery that caused Explorer 1 to suddenly turn around and face Earth. If certain celestial events had not coincided, the Explorer twins might never have left Earth. About 60 years ago, the 4 largest planets in our solar system slowly lined up in a pattern that last occurred during the reign of Thomas Jefferson in the mid-19th century. This curious planetary alignment was barely noticed at first. The first person to realize its significance was Gary Flandreau, a dual student at Caltech in 1965. At that time, space exploration was just beginning. While working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, Flandreau was tasked with figuring out the most efficient way to send a space probe to Jupiter or even farther afield, Saturn, Uranus, or Neptune. Using a simple pencil, he carefully mapped out the orbital paths of the giant planets and made an interesting discovery. In the late 1970s and mid-1980s, all 4 planets would have aligned in a way that would allow a single mission to visit them. This arrangement would mean that the spacecraft could use the gravity of each planet to blast to the next, greatly reducing the travel time. Flandreau figured that such an alignment would shorten the travel time from Earth to Neptune from 30 years to just 12. But there was one problem. This alignment of the planets only occurred once every 176 years. To take advantage of this unique opportunity, spacecraft had to be launched by the mid-1970s. NASA took advantage of this rare coincidence and created 2 spacecraft for the journey, Explorer 1 and Explorer 2. The launch on September 5, 1977, from Cape Canaveral, Florida, marked something truly extraordinary. Explorer 1 began its impressive journey into space aboard a powerful rocket known as the Titan IIIe. Just 50 days after the launch of Explorer 2 on August 20, 1977, Explorer 1 joined the space adventure and began its journey into the vastness of space by taking a more direct route. Their primary mission was to explore the gas giants of our solar system, such as Jupiter and Saturn, and their various moons. But these intrepid space explorers have surpassed all expectations. They have pushed the boundaries of exploration far beyond their limits, traveling farther and longer than any other spacecraft in history. They have broken numerous records on their thrilling journeys that have taken them through everything previously created by humans and even into a region known as interstellar space, a region that is completely alien to our system. These exploration spacecraft, Explorer 1 and Explorer 2, are currently more than 12 billion miles away from us. Despite the great distance, they continue to surprise researchers with the amazing discoveries they make there. Recently, they made a discovery that surprised everyone. The twin Explorer probes have been really great. A few years ago, they explored the moons of Jupiter and Saturn, surprising researchers who initially thought they were dark and cratered like the moons. These moons have proven to be dynamic centers of activity. Explorer 2 made history in 1986 by being the first of the twins to fly past Uranus, and just 3 years later it flew past Neptune. This is an achievement that no other spacecraft has ever achieved. As the spacecraft continued its incredible journey, NASA employed a clever strategy to keep the spacecraft running. They turned off unnecessary parts such as spare equipment and radiators to conserve energy, with the goal of keeping the spacecraft running until at least 2030. For the dedicated scientists and engineers who were part of this incredible journey from the beginning, this is a bittersweet mix of emotions. Their efforts paid off, and just when the Explorer's mission seemed to be coming to an end, a shocking discovery was made deep in space. The release of Explorer 1 included data transmission and discovery. When its remarkable journey began years ago, the Explorer spacecraft surprised analysts by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers thought were dark and very bumpy like our own moon, turned out to be dynamic worlds. Explorer 1 arrived at Jupiter in the spring of 1979, 546 days after launch. Explorer 2 followed a slightly different path and arrived in July of that year. Both spacecraft were equipped with VidCon cameras that use filters to produce full-color images. Interestingly, the device is designed to rotate through space at a rate more than 60 times slower than clockwise, making the images it captures incredibly stable and clear. During the mission, researchers took more than 33,000 images of Jupiter and its moons, each revealing new and interesting details. For example, Europa, one of Jupiter's 53 moons, has a cracked ice crust estimated to be more than 60 miles thick. As the spacecraft left Jupiter's system, the gravitational slingshot boosted their final speed to 35,700 miles per hour, a crucial step in getting them into interstellar space. At Saturn, the explorers parted ways. Explorer 1 passed through Saturn's majestic rings, endured countless impacts from tiny dust particles, passed the orange-fogged moon Titan, and headed north out of the system. Explorer 2 continued its solo journey, reaching Uranus and Neptune in 1986. But Explorer 2's achievement was overshadowed by tragedy. Just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after launch, killing all 7 crew members, including New Hampshire high school teacher Krista McAuliffe, who became the first civilian to go into space. 3 years later, Explorer 2 flew some 2,800 miles across Neptune's dazzling blue methane skies, encountering the fastest winds ever recorded on a planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, is one of the coldest places in the greater region, with a surface temperature of -235 degrees Celsius -435 degrees Fahrenheit. Another surprising discovery: lunar ice volcanoes spew nitrogen gas and particulate matter up to 5 miles into the atmosphere. After Explorer 2 captured stunning images of Neptune and its moons, both spacecraft were forced to turn off their cameras, officially ending their missions. But then came the intervention of cosmologist Carl Sagan, a member of the mission's image processing team. Even though the Grand Tour was still in its final stages, NASA extended the mission to send the spacecraft into interstellar space, renaming it the Voyager interstellar mission. The probes were determined to continue their journey into the unknown. Sagan convinced NASA to allow Explorer 1 to take a final series of images. On Valentine's Day 1990, the spacecraft turned its camera back toward the inner solar system to take a final series of 60 images. One of the images, called Pale Blue Dot, by Carl Sagan, captures Earth from an incredible distance of 3.8 billion miles. In the image, Earth appears as a tiny, barely visible against the vastness of space, illuminated by the faint rays of sunlight reflecting off the camera's optics. We've learned a lot about the planets and moons in our solar system. It's exciting to see how unique even the most distant ones are. Voyager's heliocentric journey in August 2012 was a remarkable achievement. The remarkable feat of Voyager 1 extending beyond the heliosphere was widely acknowledged the following year when a study was published in the journal Science. This is the story of Voyager's discovery. The spacecraft's plasma wave instrument detected intense solar radiation between April 9th and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered a region with a higher particle density than that found just inside the heliosphere. At first glance, it may seem surprising that the electron density in interstellar space is greater than that near the Sun. However, scientists have explained that the electron density at the edge of the heliosphere is much lower than at the Earth's surface. After analyzing the data from Voyager 1, scientists have set the official flyby date as August 25, 2012. This decision was made based not only on the movement of electrons, but also on measurements of charged solar particles collected by the spacecraft on that important day. Coincidentally, this was also the day that the famous Apollo 11 astronaut Neil Armstrong passed away. On this important date, Voyager 1 detected a 1,000-fold decrease in solar particles and a 9% increase in cosmic rays emitted from the outer solar system. These results highlight the dynamic and ever-changing nature of the space environment and demonstrate the vastness and complexity of space exploration. Voyager 1 reached an astonishing distance of 11.25 billion miles, or about 121 astronomical units, from the Sun. At this point, NASA's Planetary Science Division was constantly exploring the solar system, using a variety of methods including flybys, orbits, landings, and sample returns. But NASA has officially ended the mission, simplifying everything, since Voyager 1 has already left the solar system. The Explorer mission continued to surprise even as the probe moved beyond the solar system and into interstellar space. Now Explorer 1 and Explorer 2 are sailing through interstellar space, a place full of secrets far beyond the influence of our sun's magnetic field. Both spacecraft were shut down in 2025 due to energy depletion, and continue their journey without active communication with Earth. These spacecraft continue to travel to places no one has gone before, constantly revealing surprises and serving as an eternal reminder of the mysteries and wonders that lie beyond our solar system.